Picking up where we left off yesterday with talking about end behavior. So we had looked at the chart on page 183 and kind of discussed the chart. And we had graphed example A, and we had looked at it, and I had mentioned how to use ZBox to zoom in on that part to get what you needed. We talked about there being two extrema, a min and a max. We talked about there being 3 zeros. And then we looked at our limits. So remember, when we talk end behavior, these are the limits I want you writing. So the limit is x approaches infinity. So this says the limit as you go left on the graph. So as you trace the graph to the left, what to do. And this one was going down, so it equals negative infinity. The limit as x approaches positive infinity is as you trace the graph to the right. As you go right, this graph goes up, so it equals positive infinity. Okay, so B, what do we need to do?
Graph it.
We need to graph it.
Oh.
So, we're going to get it graphed in your calculator. I am not prepared, so you're going to be a step ahead of me.
Yeah, it is. I'm trying to get it.
So, work to get it. Once you get it graphed, sounds like it's interesting, work to get it on a good viewable screen, right?
It's annoying.
I say Sophie is very annoyed about it,
I'm
so.
also annoyed. Maybe Zoom Fit will work.
Nope.
Mine isn't even colored. So.
No.
Zoom Fit doesn't even.
Okay, 2x fourth, 2x cubed. And this is where I told you guys yesterday, I have a love-hate relationship with Zoom Fit. Sometimes it is great and gives me exactly what I need. Other times, it is horrible.
Even Zoom Out. It's
Zoom Out is
Out's
not really
nice.
helping. No.
Okay.
None of it's really working.
Oh yeah. I can do that. So then, how do you fix the or how do you?
At least we didn't get the feedback today.
That's good.
I just heard myself echo. I can deal with that. Okay. Ah.
Yeah, what is that? You just went,
Okay, so I heard Zoom Fit
Indeed.
does us nothing. I'm curious.
I
So
see.
Zoom Fit is number 0.
It's pretty bad.
I'm trying the Zoom box thing real fast.
Oh, Zoom Fit. And here's the deal, guys. You just watched it go up and down. Like, there was 4 lines up and down, weren't there?
Mm-hmm.
This is not good. No.
Why does it do that?
I
It's
don't
just
know.
like a basic parabola. It makes me feel stupid.
Right. Okay, so and there is a great example of where Zoom Fit is a massive failure. Okay. Zoom Out, you said, was not great.
No.
So if I do Zoom Out, Zoom Out actually isn't horrible. For we can't stop there. But Zoom Out actually gets me to a good spot to work with this.
I got it.
Because really what's happening, the height of this graph is pretty good. Because it pretty much shows it, if you look like it, it shows it from top to bottom pretty well. What's bad about this is the width. So one of two things I would suggest. Either one, do a ZBox. And ZBox that whole thing. And that should work pretty well. Or go to your Windows settings and change your Xmin and Xmax to something much less. I'm thinking even like 5. I don't know.
You could really go like 3, negative 3.
So I think I've done ZBox on this one in the past. Now, when I do this ZBox, I'm going to go all the way to the top. I'm going to go left of my graph there, hit enter, and then I'm going to go all the way to the very bottom. And so I box that center piece. Okay. I'm just missing a teeny bottom off the bottom corner. Could I change my Y-min if I wanted to make it happen a little bit better?
If you
Okay. So if I want to, I can go down, change my Y-min. It was negative 40. I'm going to go negative 45.
I just did that.
Oh.
I'm guessing.
Yeah.
I really don't know what it needs to be.
It works.
There we go. Okay. So we got a W shape, yes? So with this W shape that looks like that, let's talk about extrema.
Extra.
How many extrema are there?
3.
A couple.
3?
At least.
What are those 3? Well, specifically, looking at this graph, not what does our theorem say, but looking at this graph, how many physically do you see?
3.
3, because you see what?
3.
A
Local man.
minimum, a maximum, and another minimum, yes? So just kind of making, the point that there are 3 extrema, specifically of the form 2 mins and 1 max. If nothing else, that's just me trying to make sure you guys understand what extrema means. Because I felt like that was a little rough when I talked about it for the first time the other day. Understanding the idea of local mins and maxes and all that. Okay, how many zeros do I have?
4.
If you look at the graph, it crosses the x-axis 4 times. Okay, so now, in behavior. First in behavior, I'm going to write. And this, I usually try and stick with this form. The limit as x approaches negative infinity of f of x. So what am I asking here? The limit as x goes where?
Down.
Well, as x goes to negative infinity is left. Because which way did your x-axis go? X-axis goes left or right. So as x approaches negative infinity, so as we go on the left piece of the graph and we start tracing, now where does my graph go? It's going up. What does up mean? Positive infinity. Okay, so when it says the limit as x approaches, that is as x is going left or right. So as you move to the left on your graph or the right. This one was as you move to the left. What it equals is where's my graph going? And it's going up in this case. Now the other half of this when we talk in behavior. The limit as x approaches positive infinity of f of x. So what am I asking there? The limit as we trace my graph where?
Right.
To the right. So as x approaches positive infinity, that means as you're going to the right on your graph. So as I move to the right on my graph, where's my graph going? Up again. And what is up? Positive infinity. And no, you do not have to write the words left, right, up, down in there. That's me trying to give you helpful thoughts. Okay? To make it not so confusing. Because infinity, it could mean up, it could mean right. Negative infinity could mean left, could mean down. Depends on what we're talking about. As x approaches, that's a left or right. What does that limit as a whole equal? That's an up or down. Okay, questions there? Okay, so I am going to keep going notes, but unbeknownst to me, because I had failed to look, this right here, this stopping point right here, is what goes with the 2 through 8 evens, 9 through 12 all, and 18 through 28 evens. So what was listed on Monday and Tuesday. Okay? You can do everything there. So you actually could have done most of it last night. Maybe these limits would have been a little rough, because we hadn't really had a chance to really get into it. But you can do all of that now. Now, I'm going to continue, because in all honesty, I'm probably just going to make this all due at once at this rate. The way this week's worked out, it's probably going to be all due together. So you'll notice, what do I have on today's assignment? It says add 34 to 54 evens. Does that make sense? So 34 to 54 evens goes with what I'm getting ready to go into. Okay? Are we clear on the assignments? I said I'd clear that up today. I'm there. I'm clearing it up today. Okay? I'm ready for example 4 when you guys are. Example 4, the second example 4.
So you think it'll all just be due on like Friday?
I don't know. Let's talk at the end of the period when I see where I stop.
Okay.
I'm probably going to have some of it due tomorrow, I think. We'll see. Okay. Finding zeros is what we are going to focus on with the rest of this. Okay? Finding zeros and what all that entails. Example 4 is finding zeros of a polynomial. How? Algebraically. So if we want to get technical, this is what you already know, supposedly. Okay? So find the zeros of f of x equals x cubed minus x squared minus 6x algebraically. So algebraically means we're not graphing it. We're not picking up the calculator. We'll talk about that in the future. What do I mean find the zeros? Okay, so one way to think about it is x-intercepts. But we're not graphing this, so it's also just finding the solutions. When you solve an equation, your solutions are the zeros, the x-intercepts. Okay, so when it says find the zeros, solutions, x-intercepts, same thing here. And the idea, if you think about it, excuse me, when we're finding zeros, those are where we cross the x-axis. And in a zero, if it crosses the x-axis, you have the x value, but the y value is always going to be 0. So since this says f of x equals x cubed minus x squared minus 6x, we're going to take this equation and set it equal to 0. In other words, we're going to make our y value 0. So we're looking at solving x cubed minus x squared minus 6x equals 0. The 0 is an x-intercept. X-intercepts happen when y is 0. And f of x is another way to say y. Okay? Thoughts? How do we solve here?
GCF.
Do we have a GCF? Yeah. Now, do me a favor. It is a GCF. We're going to factor it out. Do not divide it away and make it disappear. If you divide it away and make it disappear, you've just gotten this problem wrong. Because you're going to lose an answer. A number, you can divide away and make disappear if it's an equation. A variable, you can't divide away variables. So if I factor out a GCF of x, what remains in my parentheses?
X squared minus x equals 6.
X squared minus x minus 6. GCF okay. Okay, guys. Turn on those algebra brains. I need you to see what we do next. You should know.
Two parentheses.
Actually, which one is multiplication? Which one is addition? I can't remember which one it is that you add. Oh,
Okay.
The one's the one you add together, right?
Okay, so Kylie just said 2 parentheses.
Sorry.
No, because I'm going to tell your classmates to answer this question.
Yeah.
Okay, so Kylie said 2 parentheses. So x out front. Sophie's questioning
3 and 2.
how do we do the numbers there? So what are we asking ourselves? We need 2 numbers that give me a product of -6 and a sum of
Okay.
-1. That's what you were asking, right?
Yes.
Like which is which. Okay,
So
so
5 and 1.
x squared breaks into x and x. What multiplies to be 6 and could subtract to be 1?
-3 and 2.
I'm going with a combination of 3 and 2. One of them is negative. Since it adds me -1, larger number negative. So -3 plus 2.
I told Mario 5 and 1. I'm so confident.
What do I do next? Okay, we're going to set each part equal to 0. How many parts am I setting equal to 0?
3.
3 of them. So we're going to set x equal to 0, x minus 3 equal to 0, and x plus 2 equal to 0. What are my solutions going to be?
Good answer.
0, 3, and -2.
I miss these things. How many of these on the homework you did?
I don't know.
Hopefully lots.
I can't guarantee they'll be that easy in homework though. Okay, now, if we were to graph this, what do we know about our graph right now?
Well, it's gonna
That's
be-
the x-intercept.
These are the x-intercepts, right? So my graph is going to cross the x-axis at 0, at 3, and at -2. Make sense? Which if this is a cubic, that means that this graph is going to look something like that, and your x-axis is going through the center, right? Okay?
That looks about right.
I typed something.
Okay. I'm not saying it looks exactly like that. I'm just using what I know about the fact that this is x cubed. So it's some variation of an x cubed graph.
Yeah, it looks exactly.
Okay. And say,
She is a map. I know, she's just so cool.
okay. Moving on. Okay. Do me a favor, guys. I need you to practice the skills. If in homework you see it says to do it algebraically, you need to figure out how to do this algebraically. Okay? Number 1 on the last test was doing something like this algebraically. And it didn't go well for everybody. Okay? So, this is review skills. So when you see algebraically, make sure you're doing algebraically. Now, if it says at the end, confirm graphically, does that mean you get to jump straight into the graph? No, that's just saying, okay, Kylie just confirmed graphically. She graphed it, and she should be able to easily eyeball that, oh, hey, yeah, my graph goes through 0, 3, and -2 on the x-axis. That's a confirmed graphically, but that's not doing it graphically, okay? Yes,
Did we get to look at our tests?
yes,
You did. I didn't get to.
we did. But when you're gone 3 days in a row for FFA, I can't really,
Yeah.
So.
I had fun.
Okay,
Santa Monica.
next page. It is, oh, and by the way, you can always see me later, and
That's what I
I
was
can,
gonna ask.
yes. I always keep them, they're always on file. You can always ask to come back and see a test or a quiz. Okay? Don't think, oh, I wasn't here that day, I don't get to see it. You
Can I
see
see
it.
it after class? Hopefully I don't forget.
Okay. It is possible to have what are called repeated zeros. So we just talked about zeros where our graph goes through that point, right? So it's possible to have what are called repeated zeros. And that is all based on the multiplicity of a zero, which I believe I threw that word out there and we talked a little bit about it in Algebra 2 last year. We talked about the multiplicity of a zero. I'm not sure it went over well in Algebra 2 though, okay? So multiplicity of 0, the ones we just did, on the problem we just did. Let me backtrack for a moment. Each of these zeros had a multiplicity of 1. They each had a multiplicity of 1 because here there was 1 x plus 2. It was just an x plus 2 to the first, so to speak. There was 1 x minus 3. And there was a single x. Those were all powers of 1 with them, yes? Those are multiplicity at 1. My graph is just going to cross through that value at the x-axis. When those powers become greater than 1, things change on your graph a little bit. Okay? So that's multiplicity. So repeated zeros, multiplicity of 0 is 2 or greater. This occurs if something can factor down into a quantity squared or cubed. Okay? So when this occurs, the graph may sometimes simply touch instead of crossing. So if it touches instead of crossing, that means it's going to go down, and it's going to be like at the bottom. It's going to turn around and go back up. It's just going to touch it and go back up. It's not going to cross to it. Or it can come up from the bottom, and so it's going to be like touching it at a min or a max type thing. Okay? So the example here, x cubed plus 4x squared plus 4x factors into x times x plus 2 squared. So at x equals -2, because I have a multiplicity of 2, it's just going to touch it there. It's not actually going to cross through. It's going to touch it and turn back and go where it came from. Now, so we're going to talk about whether our graphs touch or cross. I'm trying to remember how this is set up here.
So does that mean there's 2 zeros there? Or there's just 1?
It's a repeated 0 there. It's still just one number. If you're giving me an answer, you'll just give me the number once.
Like,
You just
so X
know
is
that it
equal.
repeats and knowing the fact that that's going to change how your graph behaves. Okay, and we'll look at some examples. Now, if the power on the factoring, so if the multiplicity is even, the graph will simply touch. Okay, so if your multiplicity or power is even, the graph will touch. Okay? If the power on the factoring is odd, the graph will still cross. And I'll show you a little bit of a difference of what it might do. Instead, it might kind of jog a little bit there, kind of take longer to cross, if you will think about it that way, but it will still cross. Both are still zeros. You still give a typical zero answer. Okay? Now, let's see. Let's look at example 5. This asks us to state the degree and list the zeros of the function. Then we're going to state the multiplicity of each zero and whether the graph will cross the x-axis at the corresponding x-intercept or if it will just touch it. Okay? So, lots of different things. Stick with me here. Let's start by talking about the degree. What's degree? Okay. The highest power in a polynomial. Polynomial is when it is all multiplied out. So I'm going to disagree with 3 because this is not all multiplied out. Now, I'm not saying you have to multiply it out. We're not going to multiply it out. If you were to multiply out x plus 2 cubed and x minus 1 squared, and you multiply that, you take all of those parentheses and you multiply it all together into one big polynomial, what's that highest power going to be? X to the 5th. Because right here, when you do x plus 2 times x plus 2 times x plus 2, that's going to give you an x to the 3rd as your highest power, right? Here, when you do x minus 1 times x minus 1, you're going to get x to the 2nd as your highest power, right? What happens when you multiply x to the 3rd times x to the 2nd? You add the powers, and it's x to the 5th. So we're going to have a degree of 5. Okay? And we're having that degree of 5 basically because it would be x to the 5th as your highest power is what you need to think about. Now, we're going to talk about, actually, I'm just going to go ahead and talk about now. If my first term is going to be x to the 5th something, right? And if it's multiplying all these x times x times x and x times x times x, is it going to be a positive x to the 5th or a negative x to the 5th term? Well, multiplying x times x times x times x times x, that's going to be a positive x to the 5th, yes? Remember that in behavior chart I showed you yesterday? Okay. X to the 5th is going to be an odd degree, and there's going to be a positive coefficient. And I know it doesn't ask for this, but I want to talk about it because I want to sketch our graph here at the end. What does that tell me about what our graph is going to look like? What's in behavior? Is in behavior up and up, down and down, down and up and down? X to the 5th is odd. Like, what else do you know is odd? X cubed is odd, yes? So what does a x cubed that has a positive coefficient look like? It starts down and ends up, yes? X to the 5th is odd and positive. What's it going to do? Start down and end up. Okay? That's important to be able to recognize. Okay? That's something that we need to be able to recognize at this level. I taught a little bit last year in Algebra 2. Okay? But that's something we've got to be able to recognize. Now, back to their problem. I probably should have saved that for later, but that's all right. We did degree. Now it asks for zeros. What are these zeros of my function? You say you guys agree with them? Because if you set x plus 2 equals 0, you're going to get negative 2. If you set x minus 1 equal to 0, you're going to get positive 1, right? So my zeros are going to be x equals negative 2 and x equals 1. Now, it wants us to talk about the multiplicity of these. Multiplicity. Well, you know when you hear me do that, that's me having to spell it out in my head as I go. Okay, so on the 0, x equals negative 2. What is the multiplicity of that? What?
2.
No.
I thought that was
Where does the multiplicity come from? It is whatever, I'm trying to see if it says up there. Okay. If the power on the factoring, called the multiplicity, x equals negative 2 came from right here, yes? What's the power on that factoring? 3. So it has a multiplicity of 3. X equals 1 came from x minus 1. What's the multiplicity of x equals 1? 2, because the power is 2, yes? So we have a 0 of x equals negative 2 that has a multiplicity of 3. X equals 1 has a multiplicity of 2. Are we okay with that? It's probably not the best. Yes, multiplicity is the power of the parentheses. I agree. Okay. Now, what does this multiplicity tell us? Okay, what do you know about the number 3? Because multiplicity, if it's even, it does one thing. If it's odd, it does something else. What do you know about the number 3? It's odd. When the multiplicity is odd, what was the graph going to do? It's going to not touch, it's going to cross. So this graph is going to cross the x-axis at x equals negative 2. What about the 0 x equals 1? What do we know about its multiplicity of 2? Okay. We know 2 is even, and a multiplicity of 2, which is even, tells us that it will touch. So your graph is not going to cross through, it's going to touch at x equals 1. Now, we say the multiplicity of each 0 and whether the graph crosses the x-axis at the corresponding x-intercept or whether it touches. I was thinking I was just doing this because I wanted to, but no, it actually says sketch the graph, doesn't it? Before we sketch this graph, I'm not saying you'd have to know this. And again, notice it is just this. It is a sketch. Are we getting fancy with it? No, it's a sketch. One other thing that would be helpful to know would be your y-intercept. We know our x-intercepts. How do you find a y-intercept?
You plug in the x.
You plug in x for 0, yes? So, if we're trying to find that, it's going to be 0 plus 2 cubed, 0 minus 1 squared. We're going to end up with what? 0 plus 2 is 2. 2 to the third is 8. 0 minus 1 is negative 1. Negative 1 squared is 1. 8 times 1 is 8. So a y-intercept of 8. Okay. We're going to sketch a graph over here. Most of our graph business is going to happen above. So when I sketch this graph, that is not the color I thought I picked. What happened? Okay. Not that it matters, but, you know, I was trying to pick like a gray or black to graph my axes in. So I've got an x-axis, and I've got a y-axis. Good enough. Now, I know I have zeros of 1 and negative 2, yes? So I should probably put those on my graph. I know I have a y-intercept of 8. So I'm going to put that on my graph. Do I have anything else?
One. Oh, did we already get one?
I have one. I don't know if you got one, but I have one.
Do not have one.
Okay. Now, we know at this point, what is going to be happening at our 0 of negative 2? My graph is going to be what? Crossing or touching?
Crossing.
Okay. Not saying you have to. I'm putting a little C down there for just for my brain. Okay? What's going to be happening at 1? We're going to be touching. And again, it's not something you have to do, but that's my brain's notation of, oh, this is what's going to happen here. And then we know we have to cross through. So we know that there's a 0 at negative 2. There's a 0 at 1. And we also know we have to cross through a y-intercept of 8. Yes? Okay. Now, the other piece of this graph we know, we talked about end behavior early on. Okay? It's going to end up and it's going to begin where? Down. So, again, I don't know anything special, but I know it's going to begin down. It's going to end up. That's just me kind of, okay, there's the visual. Okay? And we do have to, not cubic, but quintic. This is an x to the 5th graph. It's going to look kind of like a cubic. Yeah.
It's kind of a mix of both.
Okay, so can you see what's happening here? We're starting low. And as we start down here, what's the first thing we're going to do?
Cross.
We're going to cross. Now, what was my multiplicity there? Multiplicity is, on this one, a 3. The bigger your multiplicity is, the more your graph flattens out at that point. So typically when we say cross, we just think cross right through, yes? What's going to happen is when we go to do this, it's going to kind of, I don't even know if that's, it kind of just does a little jog there.
Yeah, it's very.
The larger the multiplicity, the more it will flatten out as it goes through there, okay? Now, where do we have to go now? Well, we know we have to go up through the 8, yes? And honestly, I just thought about this. Does it say it maxes out at 8? Do we know that's a max? And I'm not looking at the graph. I know some of you guys have already graphed it. I'm not looking at that. But it goes through 8, yes? And honestly, in my brain, I was kind of making it the max. Okay? And I think it's close, but it's not exactly that necessarily. But the idea is you could cross through and max over here. You could have maxed over here. I'm just trying to get up in that area. Where do I have to go next?
1.
We have to go down to 1. And what do we do at 1? We're touch. Touch is basically you're going to make a minimum there. That kind of became wonky. I don't like that either. Something like that. Okay? Now, I know some of you have graphed it. Are we in the ballpark?
Yeah.
And did all of our information make sense here? Okay. I mean, all of our details came together to make this graph. And that's the idea, is getting you guys to a point where you can look at the pieces and you can graph that. Now, do I fully expect that that's an easy peasy thing to do right now? No, I don't. Okay? I don't at all. So, but I'm hopeful that with me leading you, you can at least see the pieces there. And that was kind of my goal. Okay. Any other questions there? Okay. Next one. We might actually finish these notes. We've got 2 left. Example 6. What does it say to do? Find all real zeros. Now, notice it says here, zooming to uncover hidden behavior. What are we hinting at here? We're graphing it, okay? This one in your notes or in your homework would say solve graphically. And when you solve graphically, what do?
Plug it in the graph.
You plug it in the graph. Now, if we're looking for all real zeros, what are we looking for? What are they going to be on my graph? Your x-intercepts. Okay? Now, notice it does say zooming to uncover hidden behavior. So that's short, that's easy for saying this one's going to be tricky.
It's hiding. It's hidden.
Oh, how many?
X to the 4th plus 0.1x to the 3rd minus 6.5x squared plus 7.9x minus 2.4. I would always start off by going back to a typical Zoom screen. Oh shoot, I thought we had 10 minutes. We have 5 minutes. Right. Okay.
3 right there.
Okay, guys. Just looking. How many zeros do you think there are?
3. 4.
You know, there's 4.
4. 3.
There's 4.
They seem like they know what they're talking about.
Okay.
And then
3, 4, something like that. We know there's one off to the left, yes?
Yeah,
And then right there at that squiggle, probably need to zoom in to find that one. Okay? So, and that's exactly what I'm going to talk about is Z-box. Now, you could go ahead and find that one to the left if you want. How do we find zeros? Second calc 0. So, on the one to the left, I want to be above it for my left bound, below it for my right bound, and the one at the left is negative 3.099736, right? So I have written here it's approximately negative 3.10. To do the other 3, I would zoom in. I would definitely Z-box that little section. Because you want to know for sure what's going on. There's 1, there's 2, and there's 3. I can clearly see there's 3 more in addition to the one I already had on the left, can't I? Okay? So that's what we're looking at there. Now, you're going to have to find each of those, and that's when we're going to use our zeros, right? And I'm just going to kind of sketch this so I have something here, but the idea is, that's not exactly drawn to scale, but these are the 4 you're looking for, right? Are you finding the others? Make sure you know how to find your zeros. You're a little rusty, practice. Left bound, oops. Right bound, just to enter again. I'll just tell you the next two, but you guys have them?
1.13, 1.37.
There's my 1.13303334. So approximately 1.13. You guys agree with her 1.37?
Yeah.
Okay. Here's what I want you guys to do. Is I want you to do the homework for tomorrow, with the exception of the ones that go with example 7. Does that make sense?
Yeah.
And you're saying, but which ones are those, Mrs. Sargent? And I'm saying, give me a moment. I am thinking, gosh, it might only be 54, surely not. Surely that's not what I did. It might only be 54.
What'd you say?
Okay, so here's what I'm going to say. Do your homework for tomorrow, except 54. Tomorrow, I'm going to start by finishing this problem. I'll give you time to do 54, and we'll go over questions, and we'll probably check it at the end of the period. Does that work?
Sounds good.
Works for me.
Okay, so that way we'll we'll figure it out.
I'll just look at my test tomorrow.
Okay.